We are going to do 674b, which is 41, 41 to, let's do to 87. 41 to 87 odd. Okay. These are just trigonometric equations, so you can kind of look at them like U substitution, but I think most of them are easy enough that you can just solve them. And the first set and the second set are the same, except one's in degrees and one's in radians. Okay? So look at number 42. The cosine of 2 theta is equal to 0.5136. How would we solve this? But what if it was, let's say, 3 times 2x equals 12? How would you solve that? Divide by 3 and then divide by 2, right? Well, what if it was this? What would you do? Square both sides, divide by 2. Okay? So, let's move the cosine to the other side. And it's the arc cosine, and I'll only write this once. The arc cosine and the cosine cancel, right? But arc cosine is really just cosine -1 on our calculators. So I get 2 theta is equal to cosine -1 of 0.5136. So we type that in, cosine inverse of 0.5136, and I get 59.1 degrees. Divide that by 2, and I get theta is equal to 29.5 degrees. Now that's not the whole story. So first off, we need to make sure that that angle is inside the domain. Is it? Yes. Okay. Are there any other angles that will also be inside that domain? Well, let's look at the original problem. When does the cosine equal about +1/2? Which quadrants? Where is the cosine positive? 1 and 4. So this angle right here is 59.1. And then I cut it in half, and I get 29.5. Right? Okay. Where else is the cosine positive? Quadrant 4. So this angle would be -59.1, or the positive version of it would be 360 minus 59.1 would be 300.1 degrees. Okay? So 300.1 is equal to 2 theta. So how do you solve for theta? Divided by 2, and I get 150.05 degrees. Oh, I see, 0.9. So I have to find every answer that is within one rotation. So I solved, and I got this, right? That's in quadrant 1. That angle cut in half is this angle, and that's one of the answers. But how many times does this equal that in one rotation? 2. Once in the first quadrant, and once in the fourth quadrant. So 59.1 is one of the terminal sides. Cut that in half, and I get 29.5. But this angle also gives me positive 0.51. So that angle is 309 degrees, which I got by subtracting 59 from 360. And now this angle is equal to 2 theta, and I cut it in half, and I get 150.45. Okay. Are there any other angles that you can cut in half and still land in one rotation? The next one would be 360 plus this, right? 360 plus 59.1. If I cut that in half, then I get 209.55. Is that inside one rotation? Yes. Okay. If I take this one, which is 300.9, and I add 360 to it, plus 360, and then if I divide that by 2, am I still within one rotation? Yes. So this one actually had 4 answers. Okay. Okay, so let's do 44. The secant of theta over 2 is equal to 1.4275. What do I want to do to start? I want to say the cosine of theta over 2 is equal to, and you can just do 1.4275, and you can just hit this inverse button, and that will flip it upside down and calculate it for you, 0.7. Or you could do 1 divided by 1.4275. Okay? So, where does the cosine equal positive? We will eventually, but last time I did it that way, and I think I confused you guys. So, we're in quadrant 1, or we're in quadrant 4. Okay? So, we're going to take the inverse. These cancel, and I get theta over 2 is equal to the cosine inverse of 0.7. So 45.5 degrees. Okay, times that by, so this is 45.5, and this is also negative 45.5. Does everybody get that? So I'm going to times this by 2, and I get 91. 91. Okay, is 91 in the possible domain? Yes. Okay, if I took negative 45.5 and times it by 2, I would get negative 91. Is that inside the domain? No. Has to be from 0 to 360. That's what the problem says. So what is this angle? So it would be 360 minus 45.5. If I double that, no, it's 360 minus, so we'll double it in a second. 45.5. That's the angle. Times that by 2, it's not in the domain, so this is our only answer. Okay? Okay, let's do another one. 28. Square root of 3 secant of 2 theta. Oh, I'm tired of secant problems. Let's do number 21. That's part of your set. Or, sorry, I'm on the wrong. Never mind. 46, 48. Let's do 48. It's a cosine problem, but whatever. So 3 cosine of theta minus the square root of 5 equals 0. So the cosine of theta is equal to root 5 over 3. Everybody agree? Okay. So what quadrant are we in? It's quadrant 1 or quadrant 4. So I'm going to do the cosine inverse. And I get theta equals the cosine inverse of root 5 over 3. So this angle is 41.8 degrees. What is this angle? So it is negative 41.8, but that does not. So 360 minus the answer, or 318, and both of those are equal to theta. So in that case, we're done. All right, let's do 41. That's part of your set. That one had 2 answers, yeah. The sine of 2 theta is equal to negative 0.7843. Where is the sign negative? So I'm in quadrant 3 or quadrant 4. So I invert the sign. So the sine inverse, of negative 0.7843, and I get negative, so 2 theta is equal to negative 51 point, we'll just say 7. Make that easy. Okay. Where is negative 51.7? It's in quadrant 4, right here. Negative 51.7. But that's not one of my possible angles. So we'll say 360 plus the answer is 308. So this angle is 308.3 degrees. So now this is equal to 2 theta. So now I divide it by 2, and I get 154.17. Now, Corbin asked a really good question. Why did I wait to divide until the end? Because this angle together has to land in quadrant 4. Okay? So I put the angle in quadrant 4, figure out what it is, and then divide it by 2 to figure out which angle I times by 2 to get an angle in quadrant 4. No, I always did it at the end. Okay? Now, this is one of the possible answers. Okay? What is this angle? How will I find that angle? 180 plus 51.7. Everybody see that? So 180 plus 51.7. This angle lands in quadrant 3. So the sine of 231.7 is this. But what angle do I plug in here to create 231.7? Half of that. So I divide it by 2, and I get 115.85. Am I done? Okay. Now am I done? Well, I need to check the bigger angles, right? So let's check this one. What will that be? Hold on. So it's going to, I need to check this angle here. Well, so 360 plus 180 plus 51.7. So 360 plus 180 plus 51.7. Now that angle lands in quadrant 3. And I want to divide it by 2 to figure out which angle I multiply by 2 to take the sine to get that measure. Now, is 295.85 within the domain? Yes. So 295.85. Do I need to check another one? We better. So now I'm going to check this angle, which would be 720 minus 51.7. So 720 minus 51.7, 668.3. So 2 full rotations is 720, and I'm 51 degrees short of that. Divide that by 2, 334.15. Should I check the next one? No, it's not going to work, but I'm going to show you anyway that it won't. So the next one would be 2 full rotations and an extra 180 and an extra 51. So 720 plus 180 plus 51.7. That angle lands in quadrant 3, but when I cut it in half, it does not fit in one rotation. Now, somebody check the back of the book. Are those the 4 answers? Yeah? Okay, good. Okay, let's do 43. The tangent of theta over 2 is equal to negative 0.2343. Okay. Where is the tangent negative? 2 and 4. Okay. So I'm going to invert the tangent, negative 0.2343, and I get negative 13 degrees. Well, so the sine inverse will tell you 1 and 4. The cosine inverse will tell you 1 and 2, and the tangent inverse will tell you 1 and 4. And then you have to make the other one up. That's just... Oh, well, that's the point here, is that you know how to transfer back and forth. No. First, we have to figure out what the... So let's think of it this way. The tangent of x is negative 0.2343. So x is negative 13.18. But there are other possibilities for x. How many angles are there that land right here? An infinite number. Okay, so x could be negative 13.18 or 360 minus that. So it could be 346.81, or I could add 360 to that, and it could be 706.81, but it could also be this angle. How big is that angle? $180 minus 13 point, I'll just say 13.2. So it could be 166.8, or I could add 360 to that, 526.8. So x could be any one of those, right? But x is equal to theta over 2, right? So if I multiply by 2, theta is 2x. So if I take this list here and I multiply it by 2, how many of those answers fit the domain I'm looking for? This one is too small. That one is too big. That one is too big. This one works, and that one is too big. Yeah. Does that help a little bit? Right. So the answer is 166.8 times 2. It's going to be 333.6. That's our answer. Yep, that is our answer. Okay, 45. 5 cotangent of theta minus 9 equals 0. So the cotangent of theta is equal to 9 over 5. But we don't have a cotangent button, so the tangent of theta is 5 over 9. What quadrant is that in? It's in 1 or 3. Okay, so what is this angle here? It's just going to be the inverse tangent. So the inverse tangent of 5/9 is 29 degrees. Okay, so what is this angle? 180 plus 29. Will there be any others? Nope, all the others are going to be too big. So 180 plus 29 is going to be 209. That one was really easy. Okay, 47. 4 sine of theta plus root 2. Well, actually, you guys can do this one. It's just like the tangent. Let's do... let's do 49. 4 cosine squared of theta plus 5 cosine of theta minus 6 equals 0. That's just a quadratic. 4x squared plus 5x minus 6 equals 0. We got to use the box. 4x squared. Why do we have to use the box? It has a 4 in front. What do we do with the box? Multiply those together. Negative 24x squared. Are there factors of negative 24 that add to be 5? 8x and negative 3x. So 8x, negative 3x, pull out a 4x, x plus 2, and x minus 4x minus 3. So that simplifies into x plus 2 and 4x minus 3 equals 0. So either x is equal to negative 2 or x is equal to 3 over 4. Okay, does everybody understand that? But what is x? Cosine of theta. So the cosine of theta equals negative 2, or the cosine of theta equals 3/4. Yes, but that one can't happen. It's bigger than 1. And what if you forget that? You're going to plug it into your calculator, and your calculator will say, error, can't do it. H cannot be smaller than A. So this one actually doesn't work. Where is the cosine of theta equal to 3/4? In 1 and in 4. So if I invert the cosine of 3/4, So all suckers take calculus. Where is cosine positive? 1 and 4. So we end up with theta equals 41.4. That's this angle. What would this angle be? So it would be 318.6. Yep, those are the only two angles that are within one rotation. Okay, let's do 53. 53 says 15 sine squared of 2 theta plus the sine of 2 theta minus 2 equals 0. So x is the sine of 2 theta. Okay? So 15x squared plus x minus 2. Nate? So we get 3x minus 1 and what? 2/5. So it would be 5x plus 2. So you factor that, and you get x equals 1/3 and x equals 2/5. Can the sine of 2 theta equal those? Yes. Now, I'm not going to use the 2 theta because it seemed like you guys like that better. So here's what I'm going to do. U is equal to 2 theta. So the sine of u is 1/3, or the sine of u is equal to 2/5. So we'll have to solve these separately. Where is the sine of u positive 1/3? 1 and 2. So here. Okay? So what angles can land right here and right here? Well, let's check. The sine inverse of 1/3. So it could be, u could be 19.5, or, so it would be 180 minus 19.5. Does everybody see that? So 180 minus 19.5. So it could be 160.5 or 19.5 plus 360, which is 379.5, or 36 or 19.5 minus 360 is negative 340.5, or 160.5 plus 360. So 520.5, or I could even do 19.5 plus 720. And I get 739.5. Does everybody understand that all of those angles either land here or land here? Okay. Now, those are u values, but u is equal to 2 theta. So theta is actually u over 2. There are an infinite number of u's out there. But how many u's divided by 2 land between 0 and 360? This one does. This one does. This one does. This one, no. This one does. This one. So 7, if we did 739 divided by 2, I'm outside the range, so I can stop. Okay, so I can cross that one off, and I can cross this one off. So my answers are all of these divided by 2. So this one would be 9.75, 130.25. What's 379.5 divided by 2? Or sorry, 80. Wow. 80.25 is what I meant. What's this one divided by 2? 189.75. And what is this one divided by 2? 260.25? Okay, am I done? No, now I need to do the other half. So, where is the sine of u equal to 2/5? 1 and 4. Or sorry, 1 and 2. The sine inverse of 2/5 is 23.6. So it could be, so u is 23.6, or 180 minus 23.6 is 156.4, or 23.6 plus 360 would be 383.6. Do I need to find a full rotation and there? Oh, it's negative 2/5? I'm sorry. So negative 2/5. So that should be quadrants 3 and 4. Now, I can still use the 23.6. It's just negative. So this angle is negative 23.6. What else would work? Negative 23.6 plus 360 is 336.4, or 180 plus 23.6, and that gives you 203.6. Okay, do I need to do any more? 203.6 plus 360 would be 563.6, and 336.4 plus 360 is 696.4. Do I need to go any further? Nope, because if I go further, I'll break 2 rotations, and we're going to divide them by 2. So now all of, well, not this one, but all 4 of these cut in half will give me theta. So this sort of practice is something you'll do in calculus a lot. What we did, we called this u, and then we called this x, and we solved it in 3 steps. We used the quadratic solving method to find out what x was, and then once we figured out the trigonometric to do of x, then we plugged in the 2 theta and solved. All right, so we get out of here at 11. So just do that first set today, 41 through 59. And if you get done, go ahead and try the next one. The next one you're going to use probably going to use the unit circle. Well, I don't know. We'll do that one tomorrow.